Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let us compute the limit of tangent x as x approaches to 0 using table of values. Hello everyone! For this video, we are going to compute the limit of tangent of x, a specific trigonometric function using table of values. Now we are going to specifically use table of values here because there are some portions, of course, values of x where x can be represented as either radian measure or degree, where tangent of x is not possible or undefined, hence the limit does not exist. But since we have specified here that as x approaches to 0, we can use the table of values to specify the limit further. Of course, our f of x here is identified as tangent of x, and we are to show the limit of tangent of x as x approaches to 0. X again can be interpreted in terms of radians, the values that uses pi, or the degree measurement. Nevertheless, if you're going to use degrees or radians, as long as they are both reaching to 0 or approaching to 0 rather, you will get the same value of your limit. In this case, they just simply use radians. And instead of using the common radian measures such as pi over 2, pi over 4, pi over 3, pi over 6, let us use here values closer to 0. So we'll be using here -1 to 1 just to illustrate the limit of the tangent of x. To show the limit, of course, we need to make sure that the limit from the left of 0 is also equal to the limit from the right of 0. If it's not, then definitely the limit doesn't exist. So let's start here by x's from the left of 0. Let us use here -1, and as we go closer to 0, you can use here -1/2 or -0.5, and you can even use here -0.1 or -1/10. Let's use calculators there if you would like to. Plugging them in your calculators, you will get these approximated values. For -1, if you plug that in on our tangent of x, you will get here an approximated value in 4 decimal places. You will have here -1.5574. With this value alone, you cannot predict the limit of tangent of x. So hence, you need to use other values as we have here -0.5 and -0.1 to look further on the trend. As you use -0.5, plugging that in your calculator, you will get here approximately -0.5463. So as you can see, okay, from -1.5, it increases to -0.5. Take note of what is increasing or decreasing in terms of negative values. Let us look further on the values as we try -0.1. And in your calculator, you will have an approximated value of -0.1003. Now, to see further the values, let us try smaller values for x. -0.01. As you can see, we are using even smaller values closer to 0. -0.001 and -0.000 and then 1. Okay. As you plug this in your calculators, you will have approximated value for -0.01. You will have here -0.010 and 0. Okay, that's approximately in 4 decimal places. For 0.001, you will have -0.0010. And finally, you will have here -0.0001. As you can see that as x approaches to 0, or gets closer to 0, your f of x also gets closer to 0. This is the limit of tangent x as x approaches to 0 from the left. Okay, so let us see if we will have the same limit as we use x approaching to 0 from the left. From the right. This time we'll use the negative values of these axes here. So you will have +1, +1/2, +1/10, +0.1, +0.01, and +0.001. Okay, and slowly plug them in your calculator. The first entry will get you a positive value of this actually. if you're going to predict or and illustrate this in a graph, you would see a trend similar to that. So you will have here positive 1.5574. Okay. For 0.5, you will have here approximately equal to 0.546 and 3. As you can see, they mirror in terms of absolute value of the signs. Okay, on the table for f of x on your left, as you approach 0 from the left. Going further, you will have here positive 0.1003. Let's continue. You can try this on your own. You will have here positive 0.01, 0.0010, and 0.000 and 1. And as you can see, as x approaches to 0 from the right, your f of x gets closer to 0 as well. So this is also the limit of tangent x as x approaches to 0 from the right. And they are equal to 0. With this in mind, the limit of tangent of x as x approaches to 0 is 0 itself. Okay, other references use the ratio of tangent x being sine x over cosine x, and we have their limits as x approaches 0 in the previous two videos. The limit of sine x as x approaches 0 is 0, and the limit of cosine x as x approaches 0 is 1. So 0 over 1, that gives us 0 here. Other references also uses degrees, but basically you will end up with this value here. Now, as mentioned earlier, we have here as x approaches 0, but as x approaches to 1, that's a different story. The limit of that doesn't exist, but you can also verify that using table of values if you want to. Just make sure that if the limit from the left is equal to the limit from the right, then that means that limit is the limit of the general form. But if they are not equal, then definitely the limit doesn't exist. But for this video, the limit exists, and the limit is 0. Thank you very much for watching. So what are you waiting for? Subscribe now.